Yeah, what's up? It's Mr. Mangle. So I'm going to try a new way of recording these videos just to make sure that it's a lot clearer and you have everything that you need. So right now for this lesson, it's going to be on graphing inverse trig functions. So it's the next set of worksheets that you should have, but the two worksheets that I want you to take out are the worksheets on the graphing of inverse trig functions. I'm going to go to the Elmo right now and yeah, hopefully this helps. So for the skit, I've made two characters. One is, I don't know, energetic explorer number 1, and the one on the right is energetic explorer number 2. So, what did you think about yesterday's discussion of the inverse trig ratios?
It was okay, but definitely not one of Mr. M's best.
You need to cut him some slack. He can't hit a home run every time.
No kidding. Did you see the way he swung that baseball bat last week? Talk about a granny swing.
Me too. Last night, I tried graphing these inverse trig ratios on my calculator. The graphs were really cool. Of course, I have no idea what my calculator is doing to create these graphs, but they're pretty cool anyway.
Wait a minute. Did we have to do that for homework?
Nah, I just wanted to further my education and get one step closer to being ready for college. Yeah.
Wow, you're really an energetic explorer.
You too. Now, let's get to class so that Mr. M can help me figure out how to generate and analyze these really cool graphs. Maybe we can sit in the front.
Yeah.
Alright, cool. So, that was supposed to be a little funny intro of, I don't know, just a little pre-calculus skit. Something different, mix it up a little bit. So, this is the worksheet that you should have out. First of all, we're going to be talking about how to create the inverse trigonometric function graph, or the inverse sine graph. So the inverse of sine, or the arc, which is the same exact thing as the arc sine graph, from our original sine graph. So, So starting with the graphs of the sine and cosine and tangent functions, we need to create a sketch of the inverse sine, inverse cosine, and inverse tangent functions. In order to generate a graph for the inverse trig functions, we will need to restrict the domain of the original function. Remember how we said that in order to find the inverse of this function, we know that in order to find whether or not this is a function or not, all we have to do is our vertical line test. Well, based on if this is a function, to test whether this function's inverse is a function, we do the horizontal line test. Well, from negative pi to 0, let's check and see if the inverse on this restricted domain, let's see if that is a function. Nope, it hits it twice. So we know that the inverse from negative pi to 0 for the graph of sine is not a function. So we can't say that our restricted domain would be from negative pi to 0. So let's try, what if we restrict our domain from negative pi over 2 to pi over 2? If we restrict our domain from negative pi over 2 to pi over 2 and we draw a straight line and a horizontal line through every point on that domain, the inverse has to be a function from negative pi over 2 to pi over 2. So to summarize, in order to generate a graph for the inverse trig functions, we will need to restrict the domain of the original function so that no range values are repeated. So the first thing that you can't have, you cannot have any range values that are repeated. So no range values repeated. And two, we've captured all the range values in our interval. So we've gotten all the possible range values of this function over this domain. So we've captured all the range values in our interval. So once we've done this, then we can reflect the selected section over the line y is equal to x in order to generate the inverse graph. So right here, we said that whenever we did the horizontal line test, we restricted our domain from negative pi over 2 to positive pi over 2 for the graph of y is equal to the sine of x. So since we are looking for the inverse, whenever we restrict this domain, you might be asking yourself, well, how in the heck am I going to graph this? How in the heck am I going to graph the inverse? Well, the only thing that you have to do, if you remember, to graph the inverse of any function is reflect it over the line y is equal to x. So it'll look something like this. And all you're going to have to do is reflect it over that line, y is equal to x. So your function for your inverse sine, you know, is going to look, it has to look something like this, right? Well, let's not graph it yet. Let's check it out on the same graph. So if we were to reflect this, it would look something like that. However, whenever we do the inverse, what happens to the x's and the y's? The x's and the y's switch. So the x's and the y's switch. So in order to show that, what we're going to have to do is change our axes. So let's change our axes. So over here, anything that was on my x-axis is now going to be on my y-axis, and anything that's on my y-axis is now going to be on my x-axis. So we're going to have, I'm going to say every 4 I'm going to have a pi over 2. 1, 2, 3, 4, it's going to give me pi, negative 1, 2, negative pi over 2, negative pi. So to re-express this, to explain this a little deeper, you know, if you're a little confused, just hang in there. You know that in order to get a function's inverse, what are you doing? You're switching the x and the y's. So if we switch the x-axis and the y-axis, that is what we're doing in order to create the inverse. Our x-axis now becomes our y-axis, and our y-axis now becomes our x-axis. So then we're going to have on our x-axis, because we restricted our domain from pi over 2, negative pi over 2 to pi over 2, we know that if we restricted our domain just to this interval, we know that our minimum and our maximum are included in the graph of the inverse. So that's from negative 1 to positive 1. Negative 1, 1, 2, 3, 4, 5, to positive 1. So now I'm going to go ahead and graph that. I'm going to go ahead and graph the inverse sine function. So I know that at pi over 2, the inverse sine is also at a positive 1, and that at negative pi over 2, the inverse sine of x is at negative 1. Well, whenever I reflected it, what happened? I reflected it, and that made my graph do this. So that if you look at this and if you think about it, what actually happened? Well, your original sine graph over here, you can see, looks like this. If your original sine graph looks like this, we said that the inverse would reflect it over this straight line, and the inverse ended up being this dashed line, which, if we go over here to our newly created graph, this is the graph of our inverse. Think about it, and say if this graph continues. If we were to continue on to pi, what's the sine of pi? 0. So if we were to continue on to pi, we would go all the way back. If we were to continue on to negative pi, we would go to, wait, no, the sine of pi is 0, okay, and the sine of negative pi is also 0. But now can you call this a function? You cannot call this a function. Why? Because if we don't restrict it on our domain from negative pi over 2 to pi over 2, you'll see now that if I draw a straight line through this, you will not have a function. But you can see that this is just the sine function tilted on its x-axis. So it's tilted. All the x's and the y's, all they did was switch. So can we extend it from negative pi to pi for our new interval? No, we have to keep it from negative pi over 2 to pi over 2. And that is the graph of the inverse sine of x, which is the same exact thing as the arc sine of x. So, what is the domain range? What is the domain and range of this graph? Well, if we were to say the domain it means x values. So the x values that this graph works for is -1 to +1. The range of values that this graph is valid for, we said that the range is from negative pi over 2 to pi over 2. Are these included? Yes, because the values do exist at the endpoints. On what interval is this function increasing? On what interval is this function increasing? It is increasing on the interval -1 to +1. -1 to +1, the inverse sine of x is increasing. The inverse of sine of x is increasing. Is it ever decreasing? No, it's never decreasing. So, none. None. So, as a class, we started with the graph of the sine function and we generated the graph of the inverse sine function. So, once we created this graph, you should have, this part of analyzing the graph should have been extremely easy. If it is not, you need to practice. You need to practice a lot with being able to come up with the domain of a graph, the range, being able to tell where is it increasing, where is it decreasing. It's very, very important that you're able to understand the idea of how I got this graph. From the sine graph, how did I restrict the domain to negative pi over 2 to pi over 2? Because when I did the horizontal line test, for every range value of my sine of x, the horizontal line test cannot pass through the function more than one time for the inverse to be a function. So that only can occur from negative pi over 2 to pi over 2. I'll only pass through it once when I do the horizontal line test. So on that interval, that's what I said. I switch my x and my y axis because I know that when I do my inverse function, I switch my x's and my y's. And then I see that this is where my function will be after I graph it. In order to graph it, all I do is I reflect my original sine function over the line y is equal to